So now on to the other rule of integration. So this is about the sum of functions. So the integral of a sum of functions is the same as the integral of each function added together. So again, a bit of a mouthful. Let's try a real life example. So I've said here, what is the combined distance of a bike and a car after they have travelled for time t? Okay, so all we have here is the bike speed and the car speed. So how does this help us? Well, we know that distance is the integral of speed with respect to time. So the distance travelled by the bike is going to be the integral of this function bt with respect to t. Okay, and we know that the car distance is going to be very similar, except it's going to be the integral of ct with respect to t. So now we have two functions describing the distance, okay? And what would the combined distance be? Well, you just add them together, wouldn't you? So yeah, so after some time has passed, it's going to be probably the bike's not going to have travelled as far as the car, and then what I'm really saying here is the combined distance travelled by the bike and the car. How do we work this out if they'd only travelled? If we only had the speed and the time for which they travelled for, well, as we said before, we could work out the distance, then add them together. So you can see this is bt with respect to t plus the integral of ct with respect to t. Well, they're both got this respect to t thing here. So there's no reason just to bring them inside the brackets, right? And then do it this way. It's going to work out to be exactly the same. If he's travelled 5 meters, that guy's travelled 10 meters. If you work that out separately, 5 plus 10, but if you work it out together, then it's going to be the same number. And that's basically it. So the idea here being constants get taken out, and when you sum things or take away things, you can sum them together.